Hello, so in this video we're going to cover water availability and water scarcity. Share my screen. So this is for lecture 22, April 14th, to be viewed before Thursday, April 16th. So still continuing with chapter 7 of the textbook in water quantity and quality. So at the end of this lecture, would really like you to be able to identify the major quantities, sources, and geographic distribution of fresh water on a global basis, and identify the major users of water and percent use. We'll get more into percent use of water as well in the next video on water use. So many of you may already know, this answer to this question, but just want to really emphasize it. The earth, if you look at it, looks like it has a lot of water, but water everywhere, not a drop to drink. So how much fresh water is available on Earth? You can think about that, like what percentage, 50%, 90%, 5%, 1%. So many of you probably have heard the global statistic about, 97% of the Earth's water is in the oceans, and then just 3% is fresh water. But even among that 3% fresh water, you see 70% is in ice caps and glaciers. Groundwater is only 30%, and surface water, the water that we see on the, in lakes, in rivers, and swamps, is just 0.3%. So this doesn't leave a lot of water left on the earth for drinking water or other uses, and so we need to be careful not to pollute what we have. And so this is kind of a breakdown about Earth's water, kind of like the glass picture before, but a little bit more technical breakdown if you're interested. And since I often get the question about what is I think the other category, the 0.9% underground water. And so this kind of provides some things about, living things. We're mostly made of water, and, soil moisture, permafrost, all sorts of, there's water in a lot of places. So getting more into the water scarcity, 7.4.5, I thought it was good to combine with 7.3. If you look at this map, water isn't distributed equally around the globe to people that need it, or just the number of people. Luckily in the United States, you can see that we have little or no water scarcity. In California, we might argue differently with droughts in the western United States. We kind of see that physical water scarcity there in the map on the left right here. But, this, even though this is a 2012 map, it's still pretty accurate today. And hopefully you can think of like what is economic water scarcity versus physical, just not enough water like in surface water or even underground. Economic is where there is water available, and so you see this mostly in Africa and parts of Asia, South America, and they just can't access it. So it's expensive to drill wells, expensive to build dams and distribution systems, and not all countries have that ability. And of course, with climate change, we're seeing an increase in water scarcity. Also with increases in population, there's increases of demand for water. We are getting more efficient with our water, but I mean, there's still a very limited amount around. We are getting better with regulations, usually, for protecting the water we have, but sometimes we can get comfortable and forget sort of why we made those regulations in the first place and start polluting our water again. And so there is a lot of literature out there about the connection between water scarcity and conflict, even in like Syria and with ISIS. Water can be connected with poverty, not being able to have agriculture or food as much, and those kind of create the underlying causes of terrorism or of conflict, or people fighting over resources. So they might not necessarily say they're fighting for water, even though this was kind of linked to the Arab Spring in Tunisia and protests. but it is an underlying important factor and something we need to consider in the future. And there's, a lot of debate, politics, lawsuits all around water in California. So it is very much, the center of, conflict and litigation. So just to take these points home, I'll show you at the end this NASA video about water. So please remember to hopefully that you can understand these learning objectives by the end about the major quantities and sources of water and use. So thank you.
As humans, we're well aware we need water to live. Fortunately for us, we live on a water planet. But that doesn't mean we have an entire globe of H2O to use as we please. So just how does the usable water break down for us? A giant 97% of Earth's water is in the ocean, so we can't use that. 3% is fresh water, but even in that small sliver, about 2% is locked in glaciers, ice caps, and groundwater. That leaves about 1% of the fresh water on Earth that is accessible and usable by humans. Let's imagine all of that accessible fresh water fits into this tiny pool. Now we'll get to some small numbers when we look at global freshwater. There really is a small fraction of usable and accessible freshwater on this water planet, so how do we use that tiny pool? In the United States, about 49% is used in thermoelectric power production, while agricultural irrigation makes up about 31%. 11% goes to public use in our cities and towns, 4% goes into industry and manufacturing, and 1% is domestic use. The water coming out of our faucets largely comes from precipitation. Measuring how much or how little precipitation falls can impact how we live our daily lives. Elsewhere around the globe, in developing countries, agricultural irrigation accounts for about 70% of freshwater use, while industrial use is 20% and 10% for public consumption. In places where access to usable freshwater is greatly limited, knowing when and where precipitation may fall is critical to livelihoods. Precipitation replenishes these tiny reservoirs of fresh water, and data from the Global Precipitation Measurement Mission will help farmers, ranchers, and policymakers in these regions plan for periods of drought, flooding, and other extreme weather.